The greatest threat to our planet is the belief that someone else will save it.
It is both simple and comfortable to continue making unsustainable choices, but if we do not alter our trajectory, the consequences of our actions will be irreparable. As consumers, we enjoy choice, but that choice comes at an immense cost.
Of the 100 billion garments produced each year, 92 million tons end up in landfills. 52% of clothing produced is made from polyester, the most common type being polyethylene terephthalate, PET, which can take upwards of 450 years to degrade naturally. By 2030, it is estimated that 134 million tons of textile waste will be discarded each year. And as this fabric sits in our landfills, it generates greenhouse gases, releases microplastics, and continues to leach chemicals and dyes into the soil and groundwater. Furthermore, in Canada, only 14% of polyester is recycled, as current methods are inefficient, dangerous, and expensive.
There has been a shift towards sustainable clothing, but this shift is not enough. We cannot alter our trajectory unless we target the root of the problem and find a solution that prevents fabric waste from causing irreversible damage to our environment and health.
The time for action is now. We are RHS-Calgary, a team of students from grades 8 to 12 passionate about finding a solution to this problem. We present our solution, FabriFuel, an innovative and refreshing approach designed to address fabric waste while promoting sustainability. Our solution couples a complete degradation of PET and its byproducts with a microbial fuel cell to capture energy produced by the bacteria. The system works as follows.
Our system contains 3 chambers, each containing E. coli bacteria of the BL21 strain, genetically engineered in different ways. The first chamber contains bacteria 1, which is transformed with the genes for the chimeric protein PETase-metase, which depolymerizes PET and then converts it to terephthalic acid and ethylene glycol through various reactions as noted on the screen. Thus, TPA and EG travel to chamber 2.
The second chamber contains bacteria 2, which has been transformed with the genes for carboxylic acid reductase, which breaks down TPA into glycolaldehydes, which can then be broken down by endogenous enzymes, leaving ethylene glycol as the remaining product that travels to the third chamber. The third chamber contains bacteria 3, which has been altered through directed evolution. By inducing mutations using UV radiation and applying specific selection pressures, we hope to engineer bacteria 3 to be reliant on EG as a sole source of energy.
To tie the 3 chambers together, we will use dialysis tubing with a pore size smaller than 1 micrometer to keep the transformed bacteria in one place while allowing byproducts such as TPA and EG to move between chambers due to a concentration gradient. This ensures that the bacteria do not conjugate and share plasmids. We then hope to combine this system with a microbial fuel cell which contains 2 halves separated by a semi-permeable membrane. Each half contains a conductive surface to facilitate the transfer of electrons. One of these chambers acts as the anode and will be placed with the bacteria, while the other will be the cathode and will be exposed to the oxygen in the atmosphere. The electrons that gather on the anode from the bacteria will flow to the cathode, and this movement results in an electric current.
Combining the complete digestion of PET and its byproducts with the electricity generation of the microbial fuel cell has never been done before. And though this project may seem ambitious, we have conducted copious amounts of research and have created a detailed timeline for our project. We are a team of 24 students from grades 8 to 12, aware that we must act now. We are passionate and excited to take on this project, knowing that it has immense potential to promote environmental, economic, and social sustainability by reducing harmful wastes in our environment, producing cleaner energy, and ensuring intentional social practices. In doing so, Our project targets Sustainable Development Goal number 12, as we hope to use our solution to incentivize both sustainable consumption and production. It's important, now more than ever, that we take action and begin to solve the problem of fabric waste. We are RHS-Calgary, and we created FabriFuel, an innovative approach to solving this problem. FabriFuel, reducing waste, producing energy, all in a single solution.